started. Our question today is on the board. What does it mean to subtract? We're going to be paying close attention to our math language. So our title today, what does it mean to subtract? What does it mean to subtract? You've been learning about subtraction for a long time.
So we shouldn't need to do it.
Since first grade, maybe even kindergarten. However, subtraction is usually a third grader's weakest point. And I think a lot of that has to do with math language. You might know some bits and pieces of subtraction, but we're not fully versed in the language. So today we're going to be talking about the math language that goes with subtraction. What do you already know about subtraction? So thank you, that's not okay. What do we know about subtraction? Get your title down, please. Asha, what do you already know about subtraction?
That you're taking things away from the bigger numbers.
Okay, we are taking things away. I'm going to change, Asha, instead of the bigger number, I'm going to write the whole. Okay, taking things away from the whole. Whatever that whole might be. Remember, if I'm writing, you are writing. Michael, what do we know about subtraction?
That if there's like that equation, there's like no 1s in 60, and there was in 49, so you will have to regroup.
Okay, so sometimes we need to rearrange. For the language that Michael used, we need to regroup. The numbers. And the reason we do that is just to make it easier to solve. Just like we make a friendly number, the reason why we rearrange that is to make it easier to solve. Same thing here. Sometimes we need to rearrange or regroup the numbers. Make it easier to solve.
Way to give it to somebody.
Okay. So some of the reason why we might subtract is to give it away to somebody. Sure. John. Okay. So we can use addition to solve a subtraction problem. And we're going to talk about that, not necessarily today, but we will talk about this idea of using addition to solve subtraction. But I have a feeling a lot of you are already making the connection between multiplication and division, how we can rearrange those. There's a similar relationship between addition and subtraction. Very good. Very good. When we think about addition, it's helpful to think about it on a number line. Right? We had some part, and then we added more to it, and we ended up with this really long jump on a number line. So it might be helpful to think of subtraction on a number line. Go ahead and draw a number line in your notebook, just a blank one.
Not too long.
Okay. pretend we're going to do a very simple subtraction problem on this number line. 10 minus 3 equals box. I know a lot of you can probably look at that and solve it instantly, but I want to use an easy problem to draw it out so you can start seeing what subtraction looks like. Let's pretend, actually not pretend, let's start our number line at 0. When I am subtracting, it's already told me my biggest number, my largest number, my whole. I don't have any more than 10. That's my whole. So my number line is going to end at 10. I'm going to go ahead and put in the rest of my numbers. All of the numbers. There's a reason I picked a small chunk. 6, 7, 8, 9, 10. We're putting in all the numbers. 2. Do you remember when I said that the answer to a subtraction problem is that word difference?
Yes.
Yes. Think of it as distance. We're starting at 10. Whoa, why is that red again? There it goes. We're starting at 10. And I want to know the distance it takes for me to get all the way to 3. This is called our difference, but sometimes, especially when I look at it on a number line, I call it the distance. Does that make sense what I'm talking about? I started at 10, and I want to know how many numbers it is until I get to 3. That is what subtraction is asking me. So far, so good? All right, let's count the numbers. 1, 2, 3, 4, 5, 6, 7. How many numbers was in between 10 and 3?
7.
Elena? 7. The distance, the difference between is 7. Does that make sense what I'm talking about? So when we think about subtraction, we're really thinking, if these numbers were on a number line, how many numbers are in between? So difference tells me how many numbers are in between. Did anyone notice what strategy I used to figure out how many numbers were in between? Selena? A number line, but then what do they do on that number line?
You subtract.
What strategy did I use to do that though? Like I made these little hops. What was I doing?
Counting on.
Was I counting
Counting
on?
back.
Counting backwards. I was counting backwards. That's like the first strategy you learn when we're subtracting. Go ahead and turn the page. Go ahead and title that next blank page, Counting Backwards. That's going to be our first strategy for subtraction, is counting backwards. You can write the equation 27 minus 6. solve 27 minus 6 using the counting backwards strategy, what would I do? That's 7. Oh, yikes. I don't know what to do. I don't know how to count backwards. If I were to start at 27 and subtract 6 using counting backwards, what would I do? Harper, what would I do? So if I'm counting backwards, I could make a number line between 6 and 27 because I want to know the distance between those two numbers. However, this is not a big number. Could I just count that backwards on my fingers?
Yeah.
All right, let's do it together. Ready? 27, 26, 25, 24, 23, 22, 21. I'm holding up 6 fingers. That means I've gone backwards 6 numbers. 21.
What?
That says 21. Counting backwards. But what if I have a larger equation? Like, what if I had 57 minus 30? Would it make sense to count backwards by 1? Elena, would that make sense? Do you have 30 fingers readily available?
No.
No.
I don't have. You could.
Could you do it by 1?
Yeah, but it'll take a while and you might lose count.
You might lose count. Can you think of a more efficient way to subtract 57 minus 30? We're still using counting backwards. But we're going to do it when we're going to do it a little easier. Lena, what are you thinking?
You can count by 10 to 5.
Oh, we are really good at doing 5s and 10s, yes? 30. I'm going to rewrite that as 57 minus 3 10s. Because I know that 3 10s and 30 are equivalent. They're worth the same amount. They look a little different, but they have the same value.
What if you get robotic fingers?
Would be awesome.
You could have like 30 fingers robotic.
So let's count backwards, Brayden, by 10s. A little bit trickier. Ready? 57, 47, 37, 27. Yeah? So we can count backwards in groups of 1s. We can count backwards in groups of 10s. We can count backwards in groups of 5s. Any friendly number, you can pretty much count backwards. If you can count forwards, you can count backwards. Turn around. Thanks. Now, Bladen kind of hinted at this. Counting backwards can work for any equation you want to. But it might not be the best strategy. Can you think of an equation that counting backwards might be inefficient? That means not the best strategy to use? Can you think of an equation where counting backwards might not be the best strategy to use? Gwen?
Like
10,000 minus 566. Is that what you said? Yeah, that might not be the best strategy to use counting backwards because it's got really large numbers and only one friendly number. Sean, can you think of another equation that counting backwards might not be the best strategy?
1 million minus 1 million minus a billion. 200
Yeah, the distance between those two numbers is going to be really, really big. It's not likely going to be the best strategy of counting backwards. Brayden, you got one?
9 billion minus 2,956.
Yep, that might that might be another equation where it is not efficient. Could you do it? You could. You could definitely count backwards. But these would not be good equations to use that strategy for because the difference, the distance between those two numbers, stop doing that, is too big. Turn and tell your neighbor another crazy equation that is probably not going to work for counting backwards.